This is Unit 5, Day 5, Part 2. Example 28. Consider the quadratic function f of x equals x squared minus 4x minus 36. Algebraically determines the function's x-intercepts using the quadratic formula. And I don't know why they just did that. Using the quadratic formula. Express your answers in simplest radical form. Okay, so x-intercepts are when you let y equal 0. So that just means 0 is equal to x squared minus 4x minus 36. So now because we have to do the quadratic formula, your a is 1, your b is negative 4, and your c is negative 36. X is equal to the opposite of b, so positive 4 plus or minus the square root of b squared, use parentheses around that negative number, minus 4 times my a times my c, all over 2 times a. Okay, that's going to be 4 plus or minus the square root of, and that is going to be a 16 plus 144 all over 2. So it's 4 plus or minus the square root of 160 all over 2. The square root of 60, the square root of 160 breaks down to 16 times 10. So 16 times 10 is 160, which is going to be 4 plus or minus 4 square root of 10 over 2. GCF the numerator. So you're going to take out a 4 from both. When you take out a 4, you're left with 1 plus or minus. Again, you could put that 1, but you won't usually see it. Square root of 10 all over 2. Last thing, you can reduce the 4 and the 2 on the outside. So the 4 and the 2 cancel, leaving behind a 2 up top and a 1 on the bottom. So my roots are 2 times 1 plus or minus radical 10. Or you can redistribute that and get 2 plus or minus 2 radical 10. Those are my x-intercepts. Part B. Express the x-intercepts of the quadratic to its nearest hundredth. So don't forget, nearest hundredth, you have 2 plus 2 radical 10, or you have x is equal to 2 minus 2 radical 10. At this stage, you just put that in your calculator, and then hundredths is 2 decimal places. So you're going to get 8.32 as one root, and negative 4.32 is your other root. Using your calculator, sketch a graph of the quadratic on the axes. Use the 0 menu under Analyze Graph. Analyze Graph is number 6, and then 0 is number 1. Command on your calculator to verify your answers from Part B. Label the zeros with the graph. See your notes if you need it. Okay, so for me, when I put in the original function, I can then go find my minimum. So I use my calculator to analyze the graph, and I know that my minimum is at 2, negative 40. And we just did the x-intercepts. We know one is at negative 4.32, and the other one is at positive 8.32. So now, ready? Half of negative 20 is negative 10, then this would be negative 5. Again, here's positive 10. This would be positive 5. This is negative 25. Or actually, you know what? It's probably easier just to go by tens. So this would be like 10, 20, 30, that would be negative 40. Okay. So now I have 1, 2, 3, 4. And then on this side, 1, 2, 3, negative 4. And then you have 1, 2, 3, 4. Okay. And now I'm going to plot those important things. So at 2, negative 40 is my minimum. And then I have my 2 zeros at 8.32, which is going to be somewhere right around here. It's really hard to tell. Sorry, I don't know why that's popping up. And then the other one is at negative 4.32, which is here. So if I connect my zeros, that's a terrible sketch there. Then I have the equation y equals x squared minus 4x minus 36. Okay, last example here. Example 29. Which of the following set represents the x-intercepts, the zeros of that? Well, what you could do is you could use your polyroots. And if you polyroot this, it's going to give you the answers right away. Or you could use graph it and then find the x-intercepts that way. You could find the zeros. So just use your calculator. Either number 6, analyze graph, and then number 1, find the zeros. Or use polyroots. Okay, polyroots is menu 331. And it's going to give you that those are number 2. Okay, you don't have to do any algebra when it's multiple choice like that.